on. Can you? And now for something completely different. Okay, so this speech is about DevOps for Scala. You may wonder what is DevOps, what is the relationship between Scala and DevOps? Well, the point is when you do DevOps, you move the system administration in the area of software development. So you should follow the rules you follow when you develop software. For this reason, if your application is mostly done in Scala, it's worth to think that also the DevOps part should be done in Scala too. That is not a common point of view, but actually is perfectly possible, because I will show you how you can use Scala as the perfect tool to build a complete DevOps solution. So, let's start from the beginning. When you want to, this is the typical case in our application. So we mostly build a big data application. We use, of course, Scala as our key programming language, but we use also Spark. Very often you put Zeppelin as the front-end notebook to manage the Spark code, and very often also include Cassandra. So this is the area where we work, where we develop applications. When we have to do something like this, we have a big data application, we want to do something that in theory is very common, in theory. I stress in theory. So something like something deployed in the cloud, where everything is in a Docker container, and is orchestrated through, in this case, Docker Swarm. And there is a registry storing everything, and all the images, because Docker uses images, are built through Jenkins, and everything is taken from Git or any other version control system. So in theory, this is the standard. In practice, is not. If you try to go on the market looking for the available out-of-the-box solutions, you will find out Cloudera, Hortonworks, Mesosphere, CoreOS, and none of those is exactly a symbol like that, and they are not completely Dockerized, and they have different limitations that make it difficult to have something as a symbol as the mission statement I just said before. Probably the closer is Mesosphere, but Mesosphere is also somewhat proprietary. It's using Mesos, so there are various reasons because we stopped using it. So what I want to say is that when we want to build an application, we don't really want something as big like an aircraft carrier. Because when I use Cloudera or Hortonworks, I feel like that way. You have everything that is managed through complex user interface, so you live in the, I would say, old vision of system administration with a complex interface that will do it all for you. And but if you have DevOps, your view of the world is very different, because you want to automate. You want things are done by script, not by user interface. Things must be small, as simple as possible. So I don't want an aircraft carrier like Cloudera. I want something smaller, as simple, like a sailing boat. Also, this is a diagram that is not scientific, it's just they are put together to show an idea, but it says some truths. So normally when you take a big third-part distribution, in this case we tried with Hortonworks and Bari and try to customize. If you have a very little amount of customization, things are easy. You can just change a few parameters and you are done. But when you want to do a big amount of customization, things become so complex that you do better to do things from scratch. And this is what I wanted, and none of the available solutions were providing out of the box this for me. I wanted something that is running in Amazon Web Services. Okay, almost everything works in Amazon with different success, actually. Amazon Web Services. Everything should go in Docker. Yeah, in theory, because okay, I can tell you more about this. And everything should be built with Jenkins. I want something that is easy to customize, easy to orchestrate, and is the cheapest. This is a key point: the cheapest solution in the cloud, because things in the cloud are very expensive. And if things memory is extremely expensive, if you put in a cloud application also a user interface, a control manager, a scheduler, a lot of those things, they sum up, and your cost becomes very huge. So for those reasons, in the solution we built, we did not want Hadoop. Okay, I know that everyone here loves Hadoop. Also, I love Hadoop too. I like it. But when I build an application in the cloud that uses Spark, I don't have a strong need of Hadoop because I can just use S3 for storing data. I can use Hadoop and Spark. So Hadoop eats a lot of precious memory, and it sums up it is expensive, especially when you have very big clusters. And also another problem you may have when you try to use an existing distribution like Ambari is that sometimes you are stuck with a given version of a component, and instead you may want a newer version, and this is difficult because in a distribution typically components are related to each other, and it's pretty difficult to update one component than another component. So what I did, and I also released it as an open source project, so it's completely free. It's available to this GitHub repository. I built a project I call Mosaico. I am sure that you understand what Mosaico means. And this is not a distribution. I am not even thinking. I'm not thinking to go in competition with Cloudera. Of course, I cannot. It's not even thinkable. It's not a framework. It's just a starter kit. A starter kit, what is a starter kit? A starter kit, we developers are very used to it. Use Maven. With Maven, you typically build using a Maven archetype. It's very typical. You start an application with a starter kit. You can download from GitHub. You do the same for JavaScript, for Scala. Scala, there is the SBT tool that there are a lot of starter kit on GitHub available. So what is Mosaico? It's basically a starter kit for building a Devops application that is very specific for Scala, because it's not only because it uses Scala tools for doing most of the DevOps work. And I will show you that this one was built to reaching the goals I just described. So it's a starter kit that it should be easy to customize. So something you can take, change. It's not done to do something you cannot change. It's there as simple as possible, exactly for the purpose to let you to customize to your needs. And this starter kit creates this cloud using AWS with CloudFormation. CloudFormation is a script. We'll see more about this later. Then it will deploy all the components using another tool very well known in the DevOps world called Ansible, and build everything using SBT, and orchestrating using Docker Compose. Actually, to build this thing took a lot of work. Well, I will show you better because I do a complete demo of the kit. So the kit is built not from scratch, but on the shoulder of giants. And of course, I used Scala as the glue language for all the pieces for building these DevOps solutions. I used the Ammonite, an awesome shell, Scala shell, is similar to the Scala console with additional features, and the very well-known standard SBT, the universal Scala build tool. Okay, it's not the only one, but it's the more widely used in the Scala world. And then the usual suspects: Ansible, I already told, Jenkins, everything in Amazon Web Services, and I use the complete Docker stack for orchestrating the containers. So now, what is actually the things I did? You know, normally the life of a DevOps today is writing YAML files, because YAML is a format, is a simplified version of JSON, and for everything you want to do, you have to write a YAML file. So you need to write a YAML file for creating a cloud in Amazon with CloudFormation. You need a YAML file for configuring the instances in the cloud. Is another YAML file. Orchestrating is another YAML file. So looks like that your life as a DevOps is writing YAML, except that you need to put all those things together, and you need to write scripts for that. So the life of a DevOps is configuring and scripting, configuring and scripting, configuring and scripting, more or less. Actually, the configuration includes scripts, so well, there's a problem. When the standard scripting language available for the cloud that are mostly Linux related. There are Azure that is not Linux, but the standard one is Bash, the born again shell, that is the standard shell for Linux. So DevOps everywhere in other world, except me, write scripts in shell, tons of shell scripts. Also, I wrote a lot of shell scripts to be tired of writing them, because when I write shell scripts, I feel like a dinosaur, because it's very ugly. People say that's a good programming language. I don't think so, because I like writing scripts also using the language I use. I love that's of course Scala, and I feel an astronaut when I can use Scala. So my goal was to be able to do whatever, all the scripting needed to build in DevOps application using Scala. And this is the reason because I'm doing this speech. I'm trying to show that you can use Scala as a a very good scripting language for your DevOps needs, and I really honestly believe that is a very good solution for doing a lot of work. And I only did a real-world example ready to go. You can download and use for your needs if you want. Just to demonstrate, I cannot do more than this. And so the key is the Ammonite shell. Ammonite is a shell. Ammonite is actually a Scala console. Something like you can use, like when you type the Scala command, you can type your code directly at the prompt. Ammonite is at the core the same thing, just improved. But Ammonite has a number of features that allow you to do scripting like you would do in shell. So, for example, this is a symbol example of something you normally would do with a shell script. So, for example, you want the IP of all the instances you create in the cloud. You create a cloud. The cloud will assign automatically a number of IP. You want a list of the available IP. Normally, I would write this thing in shell, using commands, cutting and paste text, very, very, very bad. The same thing you can do in Scala in a very Scalish way, importing a library, then doing something nice, like a for loop, a print, something that is really Scala code. But all of this can be run on the command line exactly like a script. I can do this with connected to a terminal and run immediately, and that's it. So I have the best of both worlds. I have the power of Scala, or the libraries of Scala, and the flexibility of a script. So this is Just to know, Ammonite has been built by this guy, Lihaoi. I don't know the exact pronounce. I had a couple of mail exchange with him. He's a guy working for Dropbox in San Francisco. And the Ammonite is actually the new console for the upcoming Dotti, Scala 3.0 should be. So it's already in wide use. Ammonite is not only a Scala console, but has a number of features to do a complete scripting like shell. So you can copy file, remove file. So here there are a few examples. So you can do whatever normally you would do using the command line shell. The problem, there's a small problem. If you have a Scala developer, you are used to better development environment like IntelliJ. So the DevOps environment is a bit Spartan, you see. Is normally a DevOps works just at the terminal, giving commands, and sometimes it's pretty, I would say, not really helpful, but there's a solution. The solution I normally use is just using not IntelliJ, because IntelliJ unfortunately does not work with Ammonite yet. I hope that someone will write a plugin to replacing the Scala console with Ammonite, but this is another discussion. With just using Atom. Atom is an open source editor. I'm sure you have already seen sometime. And there is a very nice plugin that lets you to have a terminal in a panel. So what I normally do, I have just scripts, the terminal here, and then with just a keystroke, Control, and I can copy things. So I have my script collected, and I don't have to type. So it's very helpful, and you can do wonderful things like try a script on the command line, then store in a file, then copy again. So it's I feel very, very, very practical and efficient. So just to give you an idea how it works, a small demo. This is Atom. I open the terminal. I start Ammonite. Ammonite is ready. And then I go upstairs, and then I press Control Enter, and then it's automatically copied here, and I can work. So mostly my work is this. I have this shell with all the scripts ready, some snippets available, and then I invoke command. This is my control command for the cloud. This is the key point. And now I will show how from this control. With control center, I can do whatever I need. So let's come back to the target or mission. We want to build a cloud. Okay. So we have a number of YAML files. Those YAML files are there with all the configuration, but we have to script all together. And this is the script. There is AWS script for Ammonite with a number of functions already ready to go to do whatever we need. So you can create a new cloud, you can delete the cloud, you can list all the machines in the cloud, you can SSH in each machine directly from the terminal, you can start and stop, you can run Ansible, create a swarm, orchestrate, everything. So this is, again, my control center for the cloud. And this script is the entry point. Now, another thing. So far, I talked about Ammonite, that is the scripting solution. So Devops for Scala, how to use a Scala for scripting when you build for the cloud. Another important thing is building Docker images. Building Docker images is a big pain because for a number of reasons that I will tell you in the next slides. And it's a big pain, and The kit that the kit I built, Mosaico, includes those images that are Spark, Cassandra, Zeppelin, JDK, also Python. So a number, basically they are all the components that I use for building larger application that has been built in a few months of work, I would say a couple of years to work, with a lot of changes until they were reusable. And Mosaico includes this thing that is, because Docker images, actually, they are very similar to classes. This is not a class diagram, but it looks like a lot of class diagrams, because Docker images typically extend each other, and they have a relationship between them. So, for example, in the hierarchy implemented in Mosaico, you have well, everything is based on a distribution called Alpine Linux, for a reason I will tell later. Then there is a base images. These base images then split in a Python images, a JDK image. Then the JDK image will be extended, including Hadoop, then Spark, then Zeppelin, Cassandra, in a relationship that looks like. The problem is, modeling those relationships is almost impossible with the standard tools of Docker. You have to do this work again, writing scripts. So you write scripts that will build this, then this, then this, then this. Actually, this is a perfect use case for a build tool like SBT. And this is exactly what I did. I created a pretty complex, would say, kit for building this complex hierarchy of images easily, very easily, with SBT. So, for example, you see that how I model a dependency. Here, there is I'm modeling that the JDK depends on the base image with this script that will go in a SBT build file. There are actually more complicated relationship. For example, you might want to build an image using another image as build environment. That is crazy, but it's actually a very common thing you do when you build Docker images. Typically, you want to build an image, you have to compile something. So you need a compiler, but you don't want to put the compiler in the image because it will grow the image. So you want to start another image, include the compiler, compile, extract, and put those things in the original image. If you are not familiar with system administration, it can be something, but actually it's a very common problem. And in the kit, I have a build kit. So there is a build environment for building things that then can put in another images. So just actually the build environment is pretty complex. Well, don't know if I have to talk about it because this is a very system administration. Because short of time, I will skip this slide. Just explaining what is the problem really I solved. The problem I solved is Docker files are the biggest pain of Docker because they are just a collection of commands and that's it. And for this very limited by design, very limited approach by design, because they are designed to be as a symbol to be easy to replicate. For this limited approach, you have a lot of things you cannot do, a lot. So what you really need when you build a Docker image with a Docker file is to preprocess them. This is what basically everyone does in a different custom way. Some people write a script, some other people run using M4, some other using the C++ preprocessor. Everyone has his own solution. The solution implemented here is using SBT to do all this preprocessing. So before you build an image using a Docker file, I use SBT to download all the file I need, because sometimes people download the things inside the image. This is a mistake because it will increase the size of the image. So I download things. Another problem is all the file must be in a folder, and I move things around. there are no way or Docker file to declare that depends on another Docker file. And this is another thing that is done by SBT. That you can build using another container, as I said. Also, I added support for writing a separate configuration file and support for profiles. So everything to make this thing looks like a real build for a software development. And, well, this is an example of how I build an image using SBT. So the real work is here and is as simple as possible, because normally Docker files are much more complicated than this, because they have to do download, they have to do unpacking, they have to do... Instead, I look up from external property, I get the URL from there, I use a base image that is automatically built before you use it. This is a key feature. Then I download all the files, and finally, all I need to do is just to copy files. I can assure that if you want, I can show you. Go look for some Docker file and see how complicated they are, because of this limitation that you need to pre-process really before you can really do work. Then using SBT, things become very easy, because most of the work is done externally, and then you have only to copy things inside, and you are done. But well, actually, what I did is I used the SBT Docker, a plugin available, well known, but it was not enough. So I actually extended implementing another plugin I call Mosaico Docker that implements the downloadable file, the compilation using another image. This smart is able also to unpack file, removing extra unnecessary files, so external configuration files. So the kit, the Mosaico includes this extension to SBT to make it very easy to build a Docker image. So we are ready. We have this harmonized script. We have the SBT Docker, and we can build our cloud from scratch using the kit. And I'm going to show you this. Actually, everything would be done with a single command, but it has been split to show all the details of what happens when you create a new cloud from scratch. So there are 4 steps: creating the cloud, provisioning the software, building the hierarchy of Docker containers, and finally orchestrating them. Let's go, ready? So, first step, building the cloud. The cloud, as I said, is built using a CloudFormation configuration file that is driven by an harmonized script. So, well, this is what I'm going to build in the cloud. The CloudFormation file describes all the resources you are going to use in the cloud. That usually much more than people think. There are 3 instances in this case, but then you have to declare a subnet. The subnet must be put in a VPC. Then you have to put firewall rules. Then you have to allocate an IP address. Then you have to connect to an IP gateway. And finally, you have to implement a root table. So it's pretty complicated, but it's already done for you. You just use the one. This is the graphical visualization of the CloudFormation. So when you want to customize, a cloud, and all you need to do is to do this: add another instance. This is the snippet for an instance. To add another instance, change name, change API. You are done. You don't. Also, the driver script has a number of parameters that usually you don't want to change, but you can if you want. For example, if you want to change the instance type. Here I am using 2 GB instances, but if you want a 4 GB, put T2 medium and you are done. So there is also the customizable CloudFormation file and a parameter script for doing the work. And in practice, what you do is this. You remember, I use my control sender. with Atom Editor opening a cloud, opening a shell, a monite, and then I run the script. And after running the create command that will look to the configuration files, the cloud is built. Actually, I have a video to show you what happens. The video is accelerated because it will take some time. So you will see, but it's actually not so fast. So this is an example. You can see the CloudFormation configuration file for building the cloud. Just to give an idea what is it. Then I create Spark. Spark is the name of, in Amazon it's called the stack. The stack. So it's the name of the stack. So it starts to building the cloud. I am going to the Amazon website with console to see what's happening. You see there is the, this is the log of the creation of the cloud, yeah. And next. And after you have finished, the cloud is created, and interesting, after I created the cloud, I will ask Amazon to tell me what it created, to create a configuration file for next step, that is provisioning the software. It's the so-called inventory file. Actually, all of this can be done with a single command, build. But I separated to show what happens really, because the idea is that you can customize things if you want. It's a starter kit, remember. It's not an out-of-the-box solution ready to go. It's something that's expected to be used by anyone in the world is interested to have a starter kit for working, something that wants an help to start with Devops. And of course, it accepted my assumptions because I chose the AWS, Ansible, and so on. So next step is, it's possible to create a cloud using instances with all the software already there. But I normally prefer to start from a generic image and then install all the software in it. Because this way, for example, instead, I can do the same thing instead of the cloud. I can do the same thing in local with VirtualBox, or the same thing with Google Cloud. So it's on purpose that is split in different steps, because all the steps can be applied to different clouds, to different environments, also different orchestrator, and so on. So next step, we have now 3 instances empty, with not even Docker installed. The next step is to install Docker and Jenkins. Remember, I want to have everything in Docker, and then I want everything built with Jenkins, and this is what I'm going to do. The next step is running Ansible. Ansible, again, is a YAML file. This YAML file includes a number of rules about the state of the system you want to reach. And then all the instances are put together using an inventory that was generated querying the cloud. You see, you remember, I need the glue script to put together the various steps. So the first step, prepare the inventory file for the second step. And then, this is what I need to do. Run Ansible. Ansible will build the cloud, will provision all the software for me, installing Docker and Jenkins. And then, well, this is an example, because I installed Docker, and then I decided to use as orchestrator Docker Swarm. But I could have used the Mesos, or I could use the Kubernetes. I choose, well, it's a strange story, because 3 years ago, everyone was using Mesos. This year, everyone is using Kubernetes. I'm already convinced that the next year, no one will use any more Kubernetes, will use Docker Swarm. So I'm just preparing for the next step. There are very good reasons, because I think Kubernetes is gone. But anyway, if you want, you can use Kubernetes also, because in Mosaic there's already the script to install Kubernetes. It's a bit outdated, so I should update, but anyway. So this is the swarm installation. This is the swarm sorry, Ansible. Yeah, you see I'm running Ansible. Again, this will take actually at 3-4 minutes, I think. Usually it's accelerated, but it's applying all the rules to put all the systems to the expected. Okay, this is finished, and then I'm creating the swarm, and this is the swarm could have been created using Ansible too, but it's easier to write a script, and this is what I did. I actually wrote a script to put together all the things using a swarm command. Here is doing the work, and then you should tell me now that the 3 instances are put together as a unique Docker swarm, so it's like a big container, that spans 3 different instances. You see, now they are put in a cluster, so you can deploy anything, and it will be scheduled in the right node of the cluster. Okay. Last step. This is probably the most interesting thing. The most interesting thing, because now I build everything using Jenkins, and this is actually the more complicated part, because as I told you, I built a complex hierarchy of Docker images, and I did everything using SBT and Jenkins. So what you need to do now is build, and now instead of scripts, I'm just using the user interface, because in the user interface you have only to put credentials, so there is it's pointless to do automatically, because whatever you do, you have anyway to open a window to ask for the credentials. So now it's done automatically. I skip the explanation, just show the video, because we are going short of time. So I take the system has been prepared by the previous step. So just giving the 3 commands, and you are at this state. You have the cloud with Jenkins installed, with the Docker. I took a password that has been reported, and then I just have to create a user. So this again, and the only thing you really need to do now is to access to the Mosaico script, the Mosaico project on GitHub. It will download, and it will be everything. And building everything means downloading all the software for Spark, for Cassandra, for Zeppelin. Also, it will create some components that are compiled. So it's a pretty complex build, and this is done completely automatically. So here I just have to put my credentials. Okay, the password, of course. And now, select my GitHub repository. Go in, select Mosaico. Here is it. And that's it. Save, and it will run the build. This build takes almost 10 minutes. It's a very long. This actually does a lot of work. But after he did the work, you will get all those things. And the important thing that all the dependencies managed. So each image is built using another image, or is built using another image that is required. So it's pretty complex. It's pretty complex. It's the core probably of Mosaico. And we are done, almost. We have the images, we have the cloud. Now we have to create a cluster. And this is the so-called orchestrating step. You can do it in many different ways. As I said, you can use Kubernetes, you can use Mesos. I am using Docker Swarm for reasons that I'm not going to discuss here. For example, let's say I want to create a cluster using Zeppelin as the front end. Yeah, almost there. Zeppelin as the front end, a Spark master, and two Spark nodes without using Hadoop, remember, because I don't want Hadoop. And this is what I do. This is the orchestration thing. Here I am showing the images. The images that be built by Jenks automatically. Here there are no stacks and no services. Now I give the command to use the configuration file. Here's the key commands. So I'm saying to Docker to run. I'm saying to Docker to run to build the cluster, and now I can inspect. We can see now here the service list. There are 3 services now: Zeppelin, 1 worker, and a master. The worker is replicated because there are 2 workers and 1 master. And well, this now I'm inspecting the cloud to see the IP. I'm taking the IP. And after this, I go here and I put. Here you see Zeppelin. I forgot to record also the two instances for the Spark master or the Spark worker, but trust me, are there. Okay. Well, that's it. The disaster is complete. Questions?